Welcome to Study Loop.
So in this problem, we are given with a reaction equation, which is 2A in gaseous condition reacting with B, which is also gas, forming an equilibrium with the product A to B, also in gaseous condition. So first question here is to find out whether the value of Kc and Kp are numerically the same. So to find it out, first you have to know the reaction. First, you have to know the relation between Kp and Kc. So the relation between Kp and Kc is Kp is equal to Kc RT del N. So here R is the universal gas constant, T is the value of the temperature in Kelvin, and del N um, is the difference between the number of molecules of products and the number of molecules of reactants. So Kp can be equal to Kc only if the value of del N is equal to 0, in which case this whole value will be 1, and in the case Kp will be equal to Kc. Now, first you have to know if for this reaction the value of del N is 0 or not. So the del N, as we said, that del N is the number of molecules of the product minus the number of molecules of the reactant. So here we have one molecule or one mole of product being formed from 2 plus 1, that means 3 molecule of reactant. That means the value of del N here is 1 minus 3 is equal to minus 2. So the value of del N here is minus 2. That means the value of del N is not 0, and that's why the value of RT will not be equal to 1, and that means Kp is not equal to Kc for this reaction. Now in second part of this problem, we are asked to find out if it is possible to identify or to uh, make a make a difference between Kc from Kp by comparing the units used to express the equilibrium constant. So the thing here is, as we know from this chapter already, that Kp and Kc are basically equilibrium constant, and they're basically ratio of so the Kc is the ratio of the product concentration and the reactant concentration, while Kp is the ratio of the partial pressure of the product and the partial pressure of the reactant. And as you know that there is no unit in case of the ratios, since they are the ratio of same type of things or substances. In this case it's pressure for Kp, and for Kc it's concentration, and that's why there is no unit for such constants, and that's why it is not possible to identify or to separate or to make a difference between Kc and Kp from the units um, which is used to express the equilibrium constant, as there is no unit for such equilibrium constants. So this statement is also false, and the statement A is also false. Um, Now the third one is, in the third question we're asked to find out the value of if the value of Kc will increase with increasing pressure. So to know that, we have to look at the reaction equation. So in case of increasing pressure, the value of Kc will increase if the concentration or the amount of the product increase, because the equilibrium constant expression, as you have said, that it is basically the ratio of the product concentration to reactant concentration, and in this case our product is A to B. So in this case the expression of Kc will be A to B concentration over um, concentration of the reactants. So the coefficient will be raised as power of A, and we have B as another reactant. So the this is the equilibrium constant expression for this reaction. And from here we can see that the value of Kc will increase if the concentration of the product increases, or the value in the numerator increases. And when it will increase? So from the Le Chatelier principle, we can find that if the pressure is increased, then the reaction or an equilibrium will move in a way in which way there is lesser number of molecules present, because increasing the pressure decreases the volume. And that's why to adjust with the change in the pressure, the reaction equilibrium will move in a way in which it can minimize the change or increase in the pressure or decrease in the volume. So again here we can see that 2 plus 1 total 3 reactant molecules or moles are reacting to produce one molecule of the product. That means in the reactant side we have 3 molecules, and the product side we have one molecule. So that means if we increase the pressure, which will eventually decrease the volume, and the equilibrium will shift to this way to minimize the effect of the change or increase in the pressure or decrease in the volume. Because as we have said that if we increase the pressure, that will decrease the volume, and that's why the reaction will move in a way in which there is lesser number of molecules present. And since lesser number of molecules in this case is present in the product side, and the product is A to B, that means increasing the pressure will increase the concentration of A to B, or increase the amount of A to B. And eventually, since the concentration of A to B will increase, that means the value of Kc will also increase. That means the statement C, which says the value of Kc increases with increasing pressure, is true.